In this video, I'm going to be going through the three-force method. Now, I will tell you that I've taught a lot of students, and I don't think I've ever seen a three-force method as a solution in the answers, right? Like in trials, half-yearlies, whenever. But I'm going to take this attempt here to say there are definitely questions where if you look at the exam, you say, how many forces are there on this truss? And you can only count 2 reactions and 1 external force. You can say, hey, 2 reactions, 1 external force, that's 3 forces. And as long as they're not parallel, you can use this time-saving method called the three-force method. The three-force method is not for everyone, right? So some people, I like to talk, and if you've watched my Year 11 videos, you'll know that I own a ruler and a protractor, and I'm a big fan of graphical solutions, right? Because I don't need to solve things the way a mathematician does, because mathematicians, for some reason, don't know how to use a protractor. They can't just look at the answer and draw it out. You know, they need to know to the 10th decimal place. Me, I can just say, oh, look, that's close enough. But Excel doesn't know how to use the protractor. It can't look at the drawing. We have to do it with the computer. And this is the same thing, right? Here, I own a protractor. I can use that method to solve this question. It's going to be way faster, but the downside is it doesn't work well with Excel. It doesn't work with computer programming, right? Because we're looking at it visually. So a lot of students don't like things that don't fit into Excel. But it might work for you. You might be one of the people who says, you know what, this is going to save me time. We have an example here where we have a log. This is our free body diagram. We have a log that's being supported on the ground and it's being pulled by a rope in tension. So this rope here is in tension, so I'm going to call this force here T for tension. I then have in the center of gravity of the log, I have the mass of the log times gravity, mg, also known as the weight of 200 newtons, right? Now, there's a third force in this diagram, and this third force, I don't know the angle. I know that it's going to be up because this needs to balance the 200 down, and I know that it's going to have to be to the right because it needs to balance this angle, but I don't know the exact angle. So what we often do is we show that as a wavy line like this. And I say, look, I know that there's going to be some third force at the ground holding the beam up, but I just don't know where it is. But what's interesting is that if we have 3 forces that are not parallel, they must be concurrent. So in this case here, I have 2 lines. Are those 2 lines parallel? No. So it means they must be concurrent. There must be what we call a point of concurrency. And that point of concurrency is here. Now, my tradition from my first year of teaching is we write OMG, point of concurrency. Yeah? You don't have to write that. That's just a tradition that I have. Now, I know then that if I take this point and that point, I can get another line, and that this angle is going to be at that same, this force is going to be at that angle. I know that. Once I have that, I now have 3 forces. And because I own a protractor, I can then transfer those forces. Or, if you own a set of set squares, you can draw this to scale and then you can just transfer those angles. I will have shown you how to do that in class, but for the moment I'm just going to use my excellent estimation skills just to say, okay. Now, it's really important that our vectors need to be tip to tail. What that means is that if I have a dot here, if these two, or if this one here is that going clockwise or anti-clockwise relative to my dot?
Relative to the dot is going
anti-clockwise. That means they all have to be going anti-clockwise relative to the dot. So, I'm going to take this angle. Now, I know this is 200. 200? Yes. Do you want to let that person in? Okay, this is 400 millimeters equals 200 newtons. Therefore, if I say that's 400 millimeters equals 200 newtons, 200, it's going to be like 620 or something like that. 640. And this one is going to be pretty close to equal, I think. Right? Now, I haven't used my protractor, which I claim to have owned several times. But how does Copeland solve? Well, Copeland, he doesn't get the protractor and the ruler out. Instead, what he does is he uses the sine rule. So we can look at that as our option as well. The actual answer is, if this is 200 newtons, Rg, which they said was, oh, yeah, this is millimeters. So the point is, the answer is in fact, this one here is 248, and this one here down is 104. Now that's because I haven't drawn my angles well. Right? I claim to own a protractor, but I didn't use it. How would that look if we were going to do this here? Now I'm going to tell you that this angle here, I've measured with my, again, protractor, is 66 degrees, right? I've just measured that. Let's have a look at that triangle this way. So what we're going to say here is that we have our diagram. It's going to look like this. So this angle here is 15. This angle here is 66. So what does that make the interior angle?
24.
24?
Yes.
Okay. This is 90 plus 15, so it's going to be 105. And then what's this angle here?
Some forces that one. Whatever.
71
51.
No, page 61
It's 51.
51.
Because that's
51?
up to 180.
Yeah.
Okay.
Yeah, I'm pretty sure.
So if we want to find, if we know this is 200, and we want to find a side, is that what we want to do? Which side are we going to find? Let's say we're going to find this one here.
Yeah.
Right? What are we going to call that? We're going to call that reaction at the ground. And we're going to call this one the tension. That's what we named this.
Yeah.
Okay. So Rg in this case, once we have the angle, if you don't like using your ruler and protractor, what you can do is you can say, well, Rg is a value, it's a side, divided by sine 105 is going to equal 200 versus 51. 200 over sine 51. So therefore Rg, oh gee Rick, Sift. Can anyone calculate that for me? What you get?
249.
249. Copeland told me it was 248. But you know what? That's close enough for me that I'm happy.
0.5.
Yeah.
0.5. Okay, 0.5. What's a 0.5 between friends? Okay, the tension would be the same process, except the tension would be T over sine 24 equals 200 divided by sine 51.